All right, we're going to go ahead and start our lesson 10 for day 3 now. We're working on double box plots or double box and whisker plots. And I want you guys to go ahead and pause the video just for a few seconds and read this question on your own. So it says here, we are going to answer a few questions here. It looks like we're going to select, and you got to be careful here, you guys, because they want us to select the statements that are not true. Normally, 99% of the time we select all of these that are true. We'll check everything that's true, right? But this time, don't let them fool you. They're trying to trick you by putting the word not in there. And I don't want you to assume that that's what you're going to see on the test, though. Never assume anything. Always read the directions. So this time we're going to just check the ones that are false, okay? So we have some information, some data up here for wood coasters and steel coasters. So we're going to try to decide if the data for the steel coasters is symmetrical. So if you look at steel, so from here to here, 1/4 of the information is in there. 1/4 of the numbers are here, and the other fourth here, and the other fourth here, right? There's the same number of numbers in here as there is in here. The only difference is these numbers are closer together than these numbers are. But it doesn't look symmetrical. Symmetrical means like the same all on all sides, right? That's not symmetrical at all. So the data for the steel coasters is symmetrical. No, that's true. It's asymmetrical. It's not symmetrical. So I'll check that since it's not true. Okay. Next, the data for wood coasters is symmetrical. Well, it certainly looks like it, doesn't it? You can't get any more symmetrical than that, except we have two outliers over here. So if I drew a line straight, I could see that doesn't look very symmetrical either. That's kind of a tricky question. The next one, the top speeds for the fastest steel coaster is 135 miles per hour. Let's go take a look over there. So we look at steel coasters, and this is the lowest speed, this is the highest speed, and it looks like, yep, the top speed is 135. Since that's true, I won't check it this time because this time they're trying to trick us and they're saying only check the ones that aren't true. And last, the top speed for the lowest wooden coaster is 60. The lowest wooden coaster, here's the lowest speed. It's on the left side of that whisker. Yep, the lowest speed for the wooden coaster was 60. That's true. So because they got weird directions this time, I won't check it since it's true. So the answer for this would have been we should have checked the first two. Looking at this data right here, it looks like we have the information for two, like a table here where you can make a double box plot also. So to answer the first part, I want you guys to just take a second now, pause the video, and go ahead and read the information, look at the table, and then read A just to make sure you know what I'm talking about. So we see that Mackenzie, she's doing an experiment here, and she wants to see how both plants grow. So plant A had some growth, then the next week some growth, the next week plant B had some growth. And the whole point of this is she might be using different methods to grow these plants. Like maybe these guys are using a certain fertilizer, these guys have a certain type of light, and trying to see which method works best. So you can use a double box plot for that purpose, just to compare your central tendencies. So we're going to go ahead and do that for A. It says find the median and interquartile range for both plants. So they want to find the median and interquartile range right there. They're talking box and whisker, right? Interquartile range. So what we would do then, let me show you how to do this. And be honest with you, I won't have you guys make your own box and whisker on a quiz, but I do want to show you how they are made just so you see it, you have experience with it. And then answering these questions, that is what you will need to know how to do those on the quiz. But let me show you how they would make that. So if they took all this data up here and they wrote it in order from least to greatest, looks like 2 is the smallest, right? There's 1, 2 2s. And the next smallest number looks like it's 2.5. So there's 1, 2, 2.5s. And then it looks like the next smallest number is probably 3. There's 1, 2, 3 3s. And then the next smallest number looks like, well, the last number is 3.4. And if I was doing something like this where I was making a box and whisker, or even just finding the median of something, I would always count, at the very least, I'd count 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8. So you see how I caught my mistake? And actually I didn't make a mistake, right? Because this looks like a 3 comma 4, but it's actually 3.4. But I wanted to show you if you did make a mistake, let's say I did count um, 9 numbers, then I would go back and fix my answer. Okay, so let me check it again. 1, 2, 3, 4, 5, 6, 7, 8. Actually, there's 8 numbers, so I did it correctly. All right, so I put them in order from least to greatest. Now, to get the quartiles, right? So on a box and whisker, you have the smallest number, and over here you have the biggest number. Then the median goes in the middle, and you take all these numbers, and for half, this other half, you cut it in half again, and then you cut this in half again, and that's exactly where they get a box and whisker plot from. That's how it is made. So, whoops. Let me go ahead and pull that back up. It's the wrong button. Okay, let me go here. This is what I meant to do. Okay, so if I were to put these on a number line, my smallest number is 2 and my largest number is 3.4. So I might do something like this. I might make a number line where I have, uh, 2 here and maybe 4 here, right? And 3's right there. Okay. And so to make the box and whisker, you'd put the smallest number right above, right here. Then the middle, you would count like this. You'd count to the middle, 1 and 1, just like we did in the other lesson. 1 and 1, I'm finding the median, 1 and 1, and the number in the middle is your median. But if you end up having an even number, remember from our last lesson, how do you find the median if there's no single number right in the middle? Well, you find the mean of these two, right? The average of these two. So you could take these two and you go 2.5 plus 3 and then divide by 2 and to get 2.75. So the middle right here, the median is 2.75. That's where the middle goes. So on a number line here, if this is 2 and this is 3, $2.75 would be like right about there. That would be the median, right? The high number over here is 3.4, right before 3.5. Now, the way we get these interquartile ranges is to get your first quartile is going to be this half of the data right here, these numbers. We just find the median again. I just count my way in again. So I count 1 on the end and 1 on this end. 2 and 2. And it turns out we have another even amount of numbers. So I got to take these two, find the median for those two again. 2 numbers in the middle to get that first quartile. You would take those two and add them up and divide by 2, and you get 2.25. So that first quartile, this is 2.5. It'd be halfway. It'd be right there. This is your first quartile. Your second quartile, do the same thing. This half of the numbers over here, these numbers over here, just go in the middle again. What's in the middle of 3 and 3? Obviously 3. The average of 3 and 3 has to be 3. So this is what a box and whisker plot looks like. It's made from putting your numbers from least to greatest, finding the number in the middle, that's right here, and then finding the middle of the middle. The middles of the middles. If I'm saying that, well, that's not correct, but and that's how you make a box and whisker plot. So if we did that for both of these, it would look something like this. Okay, here's our box and whisker plots. Okay, so this is the one I just made a second ago, and I'll save you all the torture of doing it all again for this box and whisker and just show it to you. And now we can answer these questions. Now that you see where those box and whisker plots come from. So if they say find the median in interquartile range for both plants, that means plant A and plant B, then we have to take our data, the interquartile range. So for that first one, we would go down here and I don't know if you remember, but it was 2 and 25 hundredths. That was the first quartile. The third quartile down there, remember the average of 3 and 3 was 3. So the interquartile range is we would have to take those two and subtract them. So 3 take away 2.25, you would get an interquartile range of 0.75 by subtracting these two. These two right here we subtract to get the interquartile range. And then the median, of course, is a number right in the middle. Remember as we counted in the middle and we got those two numbers and took the average of those two? So that's how I get the answer for a question like that. I just use the graph. Okay. And so for the next plan, if I were to do the same thing, put them all in order, go straight to the middle, I would see there's no exact number in the middle, but if I took those two and I added them together and averaged, I would see that I'd get 3.1. And if I took this number right here, 2.75, and this number right here and subtracted them, I would get 0.7, the difference between those two. Okay, so what did we learn just now? Interquartile range, take these two, subtract them. Take these two and subtract them. And on a test question, it'll be easier. Like you won't have 2.25. It'll just be like 2 or 3, or in other words, an integer, or a whole number, I should say, right? Because it'll be positive. All right, so let's see. We're to graph the data using double box plot. I showed you how to do that, and write an inference. So looking at these plants here, so half of the plants are in this category. This is how much they grew. Half of these guys are in this category. This is the other half. This is the other half. Just by looking at it, what can you guys say from this? Okay. So an example would be if you compared, let's say, the medians, you can say, the middle here, growth was less than this. Therefore, whatever method you use for this plant worked better than the methods for this one. Or you can compare the interquartile ranges, or the lows, or the highs, or the overall range to make an inference. You're looking at those central tendencies to make an inference. So let's see what they said in the book here. They said both populations have similar interquartile ranges. The median for B is greater. That means the middle of B right here is higher. That's what I said earlier. Higher. That's another inference you can make. So generally, B grew faster. Okay, it's an example of making an inference using the data to make a decision. All right, let's go ahead and pause the video and try to answer this question on your own before I teach you how to do it. Okay, now, like I said before, I'm not really going to make you do your own box and whisker plot, but I did want you to look at this just to kind of think, to kind of see if you can understand box and whisker plots well enough to do this. They say you have two teams, right? You have, it looks like the Warriors, and we have the Bulldogs. All right, so it says both have a minimum of 0. So on my number line here, so hard to draw a straight line on this tablet. We'll start with 0. And it says a maximum of 8. So I only need to go to 8, right? So halfway through would be what? 4, obviously. Then this would be 2, right? And this would be 6. And you could even cut these in half and put all the whole numbers in there. So the Warriors up here, these guys, it says their minimum, in other words, the end of their whisker will go at, right here, 0, right above 0. Okay, now in a straight line, the maximum would be 8. So I go straight line over here to 8. And that's all we know so far about the Warriors. It says the Bulldogs, it says for both, right? So Bulldogs are here too, and the maximum is here also. So other than that, we don't know what the whisker looks like, except we have to make something up that represents this right here. The Bulldogs generally scored fewer goals than the Warriors. So how would that look? Fewer goals than the Warriors. Bulldogs have less. That means wherever the majority of my data lies, and this is not an exact science here, this is just an idea of the fact that if I had more of my quartiles over here for Bulldogs than over here for Warriors, then that would show that the Warriors generally, let's see, scored more? What was it? Yeah, scored more. So you would have to show, when you tried this, I hope that you knew enough about box and whisker plots to show that the medians and just more data was farther over here than it was for the Bulldogs. That would have been a correct answer for this problem. But again, that's just to make you think. I won't make you do a box and whisker on the quiz. But you do need to be able to recognize interquartile range and median from a double box plot. All right, that's it for today. We will see you guys very soon.